Okay, so what we have here a cubic function, right? It's swooping up, down, back up again. And we're asked for all the key features: domain, range, intercepts, maximum, minimum, and all these increasing, decreasing things. Which is no problem at all once you understand what these vocab words mean. But we might need a little practice at that. So let's go through it piece by piece here. Domain is asking for all the x values. And since this function goes to infinity in each direction, it has all the x values. Okay, there's no interruptions. There's no holes in the function. There's no gaps. So it's just all the x values. And likewise for the y values. Okay. Now x-intercepts, we can see two of them. And here's the way you're going to write this one. I've got two x-intercepts. We're going to write the coordinates of them. So that's going to be -4, 0. That's the first one. And then you comma separate these because it's a list. And your second x-intercept is 2, 0. The y-intercept is pretty easy to see. That's x equals 0, y equals 2, right here. And now we're ready to talk about the local max and the local min. Well, most people have a very easy time finding local max and local min because you think it's the top of a hill, right? Local max, or the bottom of a hill, local min. And that's exactly right. I want you to be careful about two things. For one thing, do not enter local max as a point. It is not a coordinate point. Okay, we don't say the local max is -2, 4. That is the location of the local max. The local max has a value of 4, y equals 4, at x equals -2. And likewise, the min has a value of 0 at x equals +2. Okay, so that's one thing. Now, the other thing is, you may start second-guessing yourself and think, oh, wait a minute, look at this. That right there is a value of 5, and that's bigger than my local max. So is it really a local max? Well, the answer is yes. The reason it's a local max is because if you are a little dude standing here, okay, you're standing on that hill, you look left, you look right, you're higher than everything else. Okay, or maybe the better math way of saying this is nothing else is higher than you. That's what it takes for something to be a local max. Okay, so if you were standing on flat ground, okay, flat ground, and then it goes down like that, that's still a local max because nothing's higher than you on this location right here. Okay, so enough about local max. This is different also than absolute max. The absolute maximum of a function is the highest point anywhere in it, which doesn't exist for this function, actually. Because if you look here, that's 5, right? You might think, what's higher than 5? Well, 6. And then you have 7, and then 8, and it goes on forever. So there is actually no local max on the right side of this function. Because even if you come up with a huge number like 1,000,000, there's always 1,000,000 plus 1. So there's no local max on the right. You only have the local max shown on this hill here. Okay. All right, so moving on, let's talk about increasing, decreasing. This just means uphill. Okay, and where is the function uphill? That's from -4 to -2 union. I'm sorry, that's not -4. That is -infinity. I was looking at the x-intercept. -infinity, because this is all uphill. Okay, this whole thing's uphill here. And the next section where it's uphill is 2 to +infinity. Okay? Notice that I'm not using square brackets when I talk about increasing, decreasing. And the reason is, if you zoom in on this point right here, if you're actually on the point right there, you're not increasing. That's not an increase. It's kind of like level. It's a slope of 0. So that's not an increase right there. We say that the increase stops just before the level point, where the slope is 0. And likewise, the decrease is from -2 to +2. Okay, and that's the only place where it's downhill. Now, where's it constant? Well, you might look at this and say, we just talked about this. It's not increasing there, so it must be constant. But this gets into one of the mathy definitions of this stuff. It's not constant either. Because, again, if you're a little dude on that point right there, it's down over here, it's down over there. To be constant, the values next to you have to be equal. They're not in this case. It's just an infinitesimal little point where the slope is 0. So there is no value. There is no location on this graph where it is constant. Positives and negatives, We all know what those are. Those are positive y values, right? So x equals -4 to x equals 2, and then union 2 to infinity. And I want you to pay attention here to the fact that we're using x coordinates. Even though I'm talking about y values, right, positive y values, we still use the x coordinates to point to them. And likewise, for the negative values, x equals -infinity to x equals -4. Those are all negative values. And this point right here, -4 itself, it's not positive or negative. It's 0. It's an intercept. So we do not include that in any positive-negative discussion.